Well, good morning, everybody. It's good to see everyone. Yeah, my name is Aron, and I'm the CTO of Olio apps. And I've been working with Andrew, who I'll ask to introduce next, for the past 2 years. My background is uh, in technology in general for the last 20 years. So with that, I'll pass it off to Andrew. Welcome, Andrew.
Thanks, Aron. Glad to be here. I'm Andrew Richards. I am the engineering leader at Backrs. But beyond that, I'm a serial entrepreneur. I've been the CTO and co-founder of multiple companies. And I've been working with Olio apps for just about a decade, on and off for a variety of projects. And I'm excited to talk about some of the great stuff we've done together and what we're working on right now.
I'm Scott, the CEO of Olio apps. And worked with Andrew like 10 years ago on another project, and then got a great chance to work with you again. So that's awesome. Olio has been around for 12 years now. And yeah, it's just fun to dive in to all the technology.
And I'm Dustin Herbolsheimer, and I'm one of the senior engineers at Olio. I've been with Olio for just over 4 years and been working with Andrew and the Backrs team for about 18 months now. And proud father of two, and that's where the rest of my time goes. Yeah, super glad to be here.
Yep, that's awesome. We're all dads. So
yes, we are.
Yep. Mm-hmm. Well, thanks for the intro, guys. Yeah. Looks like Andrew and Scott have been working together the longest, and maybe we'd love to kind of hear about that history. I know you intersected with we mentioned about 7 years ago, probably now, in a project together. Something
longer
like
than
that. Would you like to?
I think it was maybe.
I think it was 10 years ago, wasn't it?
2016. 2014 to 2016, we worked together on RealDX, and that was a video platform for like HIPAA-compliant medical platform for transmitting video. And at the time, there wasn't as many solutions as there is today around like video encoding and transport and sending video. So Andrew, maybe you want to talk about the use case?
Yeah. So the use case of RealDX was capturing medical video. Say a patient met with a provider and they wanted to record that encounter, store it or share it for later to basically create asynchronous medical video. Real-time video existed, obviously, but asynchronous it was obviously a thing that, YouTube could do it, but the big challenge was HIPAA compliance. And there really just wasn't any out-of-the-box HIPAA compliance solution to provide an asynchronous, record, transmit, store, put that through a CDN, transcode it so it can work on multiple devices. Just that tech really had not been structured in a HIPAA compliance space. And that's what RealDX set out to do. And when I joined as their co-founder and CTO about 10 years ago, Scott had been working on the project a little bit when I came on board. And so we worked together with a small team to figure out how could we leverage existing tech, how could we leverage cloud providers like AWS that did have some HIPAA compliant features, but definitely not the things we needed around the content delivery, around medical video, around streaming, around even scalability. These things we take for granted today, they just didn't exist yet.
Wow, that's pretty heady stuff right there at the frontier of cloud scalability. What would you say was the most interesting piece of cloud infrastructure you guys worked on together there? I would say, for me, it was the video encoding aspect was like one of the more challenging aspects. So handling these large files and then encoding them for multiple devices. This was before AWS Lambda existed, but SQS, or simple queuing service, did exist, and we used that. Messages on a message queue would come in, take the messages, spin up an EC2 instance to do transcoding. It would take over and do the job, and then spin back down. That was one of the challenges I remember. There was also a multi-microservice architecture.
Right. And we had to configure all these instances. We had to spool up EC2 in a specific way so that it would be HIPAA compliant. We had to be really careful about what we were sending through SQS and S3 because we dropped the artifacts in there. So there was some definite auditing we had to do. One of the interesting parts was we actually had to build a streaming engine that lived on an EC2 instance, and those would spool up to when someone requested a video, they hit our API, and we would need to have some layer of EC2 instances running at all times to absorb that streaming. But video streaming can be very expensive. So what we know, like they didn't really have auto scaling like they do today. And we actually had to construct a way, and Scott and I worked really hard on this one, to basically monitor our streaming instances and recognize when they hit certain thresholds. We had to determine when they hit this processor usage or this much memory. We basically had to come up with a construct that figured out this is overloading or will soon preemptively spool up another instance and then load balance it dynamically. So the users would never see that this video took too long to load because we were dynamically load balancing it. We couldn't just turn that on. So we had to build that with our hands tied because we only could use HIPAA compliant tools to do it. So the system would dynamically scale up and scale down. We applied the same concepts to our transcoders. We'd have to scale those up and scale down, or otherwise we could have these big long queues of videos that need to be transcoded. So today you can just check a box, but 10 years ago, 8 years ago, we had to determine how to do that on our own. It was pretty impressive because several years later, after Scott and I had both moved on and working on some other projects, the leadership team from RealDX reached out. They needed some help with it. They kept the project going. We had moved on. They needed some help. They gave me access to the stack again. And the platform that we had built had been left untouched for a pretty long period of time. And it had not gone down. It had self-healed every time. We also determined when services would fail, it would automatically recover and respool them back up. So this thing had scaled up and scaled down and just basically been living untouched on its own, thanks to all the mechanisms that we created. That was like this point of pride. I was, whoa, this thing still worked. It didn't need us to keep poking it. And that was just a testament to the trippy stuff we got to build.
Longevity of things. That's an amazing feeling, isn't it? Where it just keeps on going. Just a quick question. I imagine you had to build an agent that had to live and spool up onto the EC2 instances. Is that how it worked? And what framework or languages did you use?
So for EC2, Bill, I'm rusty on this, so I have to think back to how we did it. We actually, at least I can speak to the video streaming components. So for those, I actually pre-built a EC2 instance that would load up with all the right tools and configurations. Docker, I think, was just coming out. Like we were just experimenting with that. But you could basically build a full-on EC2 instance and save it as the unique ID. And then you could just say, spool up an instance of this code, and it would launch basically the image you had saved. So we had to spool that up. But really, we use some of the AWS tools to monitor the performance of an EC2, and it was blind. We didn't really have an agent on EC2 saying, hey, I'm running out of resources, help me. We were monitoring more or less what AWS was telling us. So EC2, we could see performance spikes and all that. And those, of course, those lag. So we actually had to kind of guess that we would go, hey, if it hits like 64% processor usage and it's increased by this percentage over the last, it's climbing, spool up now. Don't wait till it hits 90. So we have to start to be predictive about it. So that was really just a bunch of crazy rules we had to put into like the auto scalers that you could use to say, hey, when these parameters are met, launch another instance. But there wasn't really an agent because we couldn't make it communicate because we'd have to transmit data that might have broken our compliance. So it was a weird problem to solve that way.
Yeah, sort of the art of like adjusting these thresholds and figuring out, because you can't test this locally. It's a cloud native kind of architecture where you have to see and adjust to how it's operating live. Awesome. Well, that's amazing. That's that's a great project to collaborate, on. Well, I'd like to bring it a little bit closer to the present day, right? Where now, well, just about 18 or 19 months ago, Andrew, you reached out again to Scott and said you had another project to work on. and that project is your current project, which is Backrs, right?
Yeah.
Yeah, I'd like to explore that a little bit. Some of the use cases that we helped at Backrs, Olio apps, primarily Dustin and myself. Could you give us a little bit of background on what Backrs is, its mission, and that sort of thing?
Yeah, absolutely. So Backrs is an online platform that is designed to help support highly driven and potentially under-resourced young adults. We call them proteges. We onboard proteges from around the country into our platform. They go through an onboarding process to show how what they want to achieve in their life. And again, a lot of these proteges are under-resourced. They just don't have access to the pathways that could get them to, say, university or to a career field they want to get into. So with knowing what they want to achieve, we leverage our network to identify what we call Backrs. And they're more or less sponsors that come on board to the platform. They support sometimes one, sometimes many proteges. And it's a very small touch where they don't have to be involved for tons of time. They can be involved for a few minutes a week, couple hours a month, where a protege uses our platform to have an ask where they request, hey, I need someone to help me with this, or how do I apply for that? Or I'm interested in this career field. And the Backrs on their teams can step forward and say, oh, I can help you with that, and set up a Zoom call or send over resources and really provide a big network with strong social capital to help that young adult move to find success in their career and their life. We started in Memphis, Tennessee in the South and have grown all over the country. We have proteges everywhere in the country. We have Backrs everywhere in the country, and we're continuing to grow. And from there, it's been fascinating to see how this just has scaled up. On the lives it's touched, we actually have a channel internally at the company on our Slack feed that's called Wins, and we get to see updates from proteges that have been accepted to university, got scholarships, and some of these proteges were the first in their family to graduate high school. And by being connected to this network, they found success they just might not have found otherwise. So that's in a kind of a long-winded way, but that's what we're doing with Backrs, and we're continuing to scale and grow.
That's amazing. Yeah, it's really been a wonderful mission to be involved with. It's very uplifting also to be part of it. To see it, the model expand and grow and touch people's lives. And like you said on the Slack channel, real time, people saying how it affects them. It's fantastic. At Olio, we love that. We love that type of a project. So I appreciate the opportunity. So I'm gonna see if I can recount exactly what is the platform. Right. Essentially, it's on AWS cloud. It's backed by a Lambda stack. Right. And it powers an app that's actually on both app stores. And now we've just released a web version of it. Right. That's kind of like the nutshell platform. And I've had the pleasure of personally working on all parts of that stack, as has Dustin. But I'd love to talk about the kind of like the evolution of the API, the Lambda cloud stack, because about 18 months ago when I joined, it was a fairly, it worked very well. It was but a fairly kind of first level kind of API where it was a single node JS API that's deployed as a Lambda altogether, right? And we deployed everything. That works fantastically. And I want to walk through its evolution through the various use cases, right? And talk through some of the interesting things that happened. Probably the first place I'd love to talk about is when it might have been 8 months ago, probably, when we needed to expand the notification system to and that entailed some changes to the stack. I would love to, if you can, see if you can recall why we had to do that in the evolution of Backrs, and then we can launch into some of the technical details.
Yeah, absolutely. And I do want to give just a quick overview of the evolution of the tech stack. When Backrs started, it was a concept that I kid you guys not, and it was awesome. It was spreadsheets and Cash App, because we help fund our proteges too, and human outreach. We were rapid prototyping even the concept before we built tech. We used off-the-shelf tools, an off-the-shelf social network tool to put our proteges and backers together. So we really were rapid prototyping this before we even thought to go, okay, now let's build a stack. So it's important to know that's where we started. And from there, we went and took the lessons learned from just that rapid prototype getting people involved to craft what we thought would be an app forward solution. And, it's what could be, hybrid app was the quickest way we could get in both app stores. AWS was really easy for us to scale up on. That's why we went with that. Lambdas were simple for us to use to rapidly put up API and all the endpoints. So we grabbed just, kind of industry standard stuff and put together the stack, and we're iterating quickly with the goal of getting a bare bones app out so we can migrate away from these off-the-shelf tools that were incredibly limited and started to become cost prohibitive. So that's where we started. I'd like to say we kept it to friendlies. So we intentionally did not scale the company when it comes to backers and proteges while we did this. So the idea was we took the rapid prototype, set up our own app stack, migrated those users over to that, and then they helped us improve the experience until we were ready to scale. So enter what we're about to talk about, notifications. So when we had a very small user base, one of the reasons we selected a hybrid app platform was so that we could send push notifications to both iOS and Android users. For our user base, notifications actually work really well. We discovered text messages are usually ignored as our emails for our proteges. Push notifications, you usually get a response. When we had a small set of users, sending out a few hundred notifications wasn't a big deal. But as we scaled, we suddenly were trying to send out several thousand, 5,000, 8,000 notifications in groups at a shot. And suddenly we discovered some of the notifications either weren't being sent to users, they were randomly not showing up, they were failing, but we couldn't figure out why. On our stack, all the notifications appeared to being generated correctly, but somewhere between our stack and the user's devices, they were vanishing. And we went, okay, we got a problem here. We've scaled up. Like, how do we unravel that?
That takes me exactly to the place of memory. Thank you so much. I just loved hearing that story. Yes, exactly. Now we need to send more messages to reach a wider number of proteges and backers, and it has to be robust, right? Mm-hmm. So I believe the first thing we did was to actually go ahead and try to send those messages, and Dustin was in charge, right, of making the existing notification system do more. So Dustin, I'd love to hear what happened when you tried to send more messages through the pipe.
This one took us a while to figure out, to be honest. I'll just start there. We started off with our usual suspects, going through our local stack. We really narrowed in first on how we were publishing these push notifications to Google, and publishing stack, how we were looping over stuff, to looking for errors, bad responses, all of that. And again, testing in dev, everything's looking fine, right?
As it does.
Right. So eventually we moved towards, okay, well, what's the difference between, that's when we actually shifted towards the difference between our local environment to the deployed environment, in staging and Lambda. And again, frustrating because functionally the code was working as expected. And our first clue started coming in when we decided just to flood AWS with console logs. We just logged everything. Every step of the way, we'll put a log. We'll see how many messages you're supposed to be publishing, how many messages are actually being processed. And then individually, when each message is done, we'll throw a log, throwing some context about how it was handled. That's the first clues when we started seeing these differences between what's actually processed versus what we expect to be processed. In CloudWatch, we would see, let's say we'll scale it down to 100 messages for us to publish. And we would notice that we would maybe fire off this event. We would see that it would compose, the list of objects to be published. It would send them off, but then they would actually maybe only process 10 of them. And then it would just disappear, and the other 10 would just get lost. At that point, we still didn't have a clue or have really solid ideas or leads on what was going on. So we brought in Scott. for some consultation at that point. Do you remember, Scott, where we were at that point? Kind of, we called you as one of our lifelines.
Yeah, I think we started looking at the CloudWatch logs and seeing what was happening, and it was really interesting to see that like when a subsequent request would come in, it would pick it back up and start sending more notifications. And I began to suspect something in the way the Lambda environment is different than the local environment. Because one thing that's interesting about Lambda is that it's very on demand. It's not just running all the time. It runs when you make a request. If it's an HTTP Lambda, it fires up at the moment of making that request. And then when the request is finished, shuts it back down. So there's like stuff happening in the background. When you're running locally in Express, nothing ever gets shut down. It's like the process stays resident, running on the machine. On Lambda, if it's an HTTP Lambda, once you write a response to the request, it shuts the process down. What I didn't realize until while learning about this process, we learned in doing some research about the AWS Lambda environment, is that it actually, for efficiency's sake, will freeze the process and everything in memory and retain that, keep that around for a while to, that's part of like what makes it so that cold starts are lessened or not going to happen the next time a request comes in.
Yeah. So that was the next clue. And the next step is when we realized for some reason, batches of our notifications were getting handled on subsequent or, Lambda invocation, right? Part of what we run on this original one, and then the next one would start. The ones we were missing would run sometimes, and then the new ones would be processed, and then the next batch would be run. So we started looking into, okay, well, what causes Lambdas to freeze and unfreeze? And in Node specifically, it has this interesting connection with the Node runtime and the event loop. And basically what happens is functions start running, the Lambdas invoked, the call stack's created, and the functions run, and it starts stacking up functions to resolve. So it stacks up, and then it'll start resolving those. And when the stack is empty, at that point, Lambda says, I'm done running, so I'm going to freeze, right? And then, of course, in the background, that context is still alive until AWS decides to reinvoke it. So we were looking for, well, why does it think our call stack is empty? Or why does it think it's done running our function when obviously there's all these messages to be processed? Promises, of course, we checked for promises being awaited, and callback are the big one. So we went and made sure, are all the promises being awaited? Do we have any callbacks? Tied those off, and then realized that there was a library that we were using called JS Event Bus or Event Bus JS, one of the two. But what we were doing is we were creating these jobs to be processed, and then we'd send them off and register them with the event bus. And what was happening is as soon as we did that, Lambda said, oh, this function has been invoked, and all those jobs went away. So they go into whatever API is controlling or event bus was using to schedule those tasks and run them. And those tasks were not being put back into the main call stack through the event loop is actually the control that takes events from a task queue, things like set timeout. Those functions, they come back onto a task queue. The event loop picks them back up when the call stack's empty, puts it onto the call stack, evokes it. What's happening is AWS was saying, okay, we're done running, and it's going to shut down before event bus could throw events back onto the task queue be picked up by the event loop. Shuts down, and then it gets opened back up, and all those events that were queued up are now run first, which is why we would see those notifications being processed on the subsequent request. Technical story short, basically, it thought it was done, it would shut down, and then when it wake up, it would process everything that it was waiting on.
That's we've colloquially called that the Heisenbug, Lambda Heisenbug. and more on that terminology in a second. But do you recall what we did to actually fix that? Had the in-memory event bus.
Yep. This is when we actually planted the seed for our kind of new event-driven architecture, which we'll talk about later. But rather than use the event bus, we switched over to the simple queue system, the SQS. So rather than publishing these or registering these events with event bus, we just published them to an SQS queue or an SQS and assigned a handler to pull those messages in and consume them. And our problems went almost immediately away.
Almost.
Just that.
I would call that creating another problem.
Yeah. But fundamentally, offloading our asynchronous jobs to another cloud service, AWS SQS, unlocked our ability to efficiently and effectively, reliably run asynchronous events without dropping any work.
Yeah. So that means that notifications are now reliably delivered, right? And kind of helped with that.
And more reliably debugged. I mean, everything that comes with it. It's much more easy to resolve issues that pop up now.
Awesome. So fast forwarding a couple months later, Andrew, there was an initiative that was brought up now that had also to do with notifications, right? Also. And I think that was when we needed to have more scheduled notifications. Would you mind giving us some background on what that was?
Yeah, absolutely. So once we resolved the pipeline of notifications and we could reliably send them, we advanced the software to say, instead of notifications being purely driven by action, where, let's say someone made a post and we wanted to notify certain users, we wanted to use notifications to help drive engagement. And our community team at Backrs had been doing this manually one way or the other. They would trigger certain events. Like I mentioned, text didn't really work that well, so they were trying to use text. But really what they needed to do was, when certain thresholds were met, say a user hadn't logged in a few weeks, we wanted to reach out to them via push notification. Or when a user had done certain things that were great, we wanted to automatically send them updates. They had made a certain number of posts. They had responded to Backrs, or there's just a bunch of parameters that we had come up with. So we worked with the product and the community teams inside of Backrs to identify more or less a rule set of, if this, send that, and built a logic set around that to say, okay, in these scenarios, we need to send notifications to these users. And some of these would be time-based, right? Like once a week, we wanted to remind people to do something. Other would be, if certain things happened, they'd fire off. So there was could happen at any time element. There was a needed to be checked every morning element. There was a once a month kind of thing. So there's a whole range of rules. And we need to figure out how to translate that into some kind of way to send notifications through this newly scalable event, SQS and handler to our users.
Yeah, I remember that mission. That was very fun, because it was a challenge to take what we already had, and improve it to do a little bit more. And and Dustin, you spearheaded that effort as well. Maybe you could discuss a little bit of the architectural changes we made to the at that point existing situation. So we started with Lambda processors on SQSQ.
So with our scheduled notifications, we called them direct messaging jobs, or automated direct messaging. We leveraged our existing S2S system to handle these text messages that was already handling jobs. The next piece was, okay, what tools are available to run a multitude of tasks, as Andrew described, event-driven, pre-scheduled, and then events that are relative to certain other events, right? So kind of jobs that span a number of different rules. We leveraged the AWS EventBridge and Event Scheduler services. So if you will, EventBridge is AWS's event bus. Think of that, the event bus that we got rid of locally, we are basically now trying to replace it with the AWS service. And so imagine, event bus, you can put events into it and it runs, and then certain handlers are basically assigned to listen to events that are running through that pipe, pull them out, handle them, leave them in so other handlers can pick them up, downstream. The job scheduler is basically a service that we use. We schedule using cron expressions, and that will periodically put events into the bus, right? Just inject them into the stream, and then we assign a handler that will basically, that the event would tickle that handler, wake up. There's context inside that event that would tell this job to do something. In this case, it would wake up, it would find the event, it would say, okay, for this particular event, I got to segment my users, right? We call it a segmenter. They would basically go through and say, whoever should get this notification for this particular job, we'll build those objects, and then we'll publish those to the existing SQS queue that we already had set up for these messages. So it's just another piece in the event-driven architecture that we're working towards to drive this new functionality. I like how Riverside does the automated messages too. I didn't know that.
It's good to know.
Yeah, interesting. Yeah, and also as part of that, you were able to capture context about the users, like important things that we don't have to compute at the time when that segmenter runs. So whenever you last login, we would actually record that in a way that is efficient. So you don't have to recompute, like say 1,000 people's last login each time. And I remember that being a critical piece of the infrastructure. Yeah. But so that was a nice little expansion of that framework. Yeah, Andrew, any other comment about that?
Yeah, that was great, just value add and additive expansion of that. I also want to mention, I mentioned earlier, we created another problem. Is once we had figured out the notification pipeline, we built a really good one to the point it was now overwhelming our notification engine, that it couldn't set, like we were saying, hey, send these 5,000 notifications, and it would say, no, I can't. So then we had to build, Dustin knocked this out. He had to build a tool that would batch them, and it was smart enough to go, oh, here's 5,000, now you get 50 at a time, and would validate that they had sent and give us this quality of service check where we could say, yes, this has been delivered. And if not, this is why it failed. This device had not been registered. So there's all these little quirks that once we had figured out that, yes, we are effectively sending notifications, it unraveled a bunch of other things. We had to build some downstream quality of life checks that shored that up. And I'd be remiss if we didn't mention that, because it added a bunch of work that we weren't ready for. And then once we discovered it and we fixed it, it took a little bit of time, but now we're highly confident in how those notifications are sent. And the majority of questions out, did the notifications still work right now? Those are gone. We got this sorted out. So I just want to point out that we added that at the tail end once we got this flow working efficiently.
Yes, absolutely. I remember when all of a sudden the types of errors coming from the fields was no longer notification based, and it was a very distinct signal that something new and good has happened.
Yeah.
Well, so yeah, that's right. Thank you for helping us remember that. And I love these kinds of talks because it's sort of a lot happens, right? And it's very rich. I'd like to take us up to almost basically the actual literal present day, where now notifications are not so much of the issue, but we need to still always foster more engagement from the community, right? And so that brings us up to the current initiative that we're working with right now, which relates to in-app banners. Maybe you'd like to give us a little bit of a background on that, Andrew, and what it is and why we need it.
Yeah. So as with many apps, when you log in periodically, you'll get a call to action. And sometimes it's an overlay that says do this, or a banner pops down at the top of your feed or whatever social media tool you're using that asks you to engage in some way. We've always had those. We've had things where we encourage the user to fill in their profile. We love to capture data around users so we can more effectively match them with proteges and provide other training and services. We also would have things in there related to checkout. We used to have some training stuff in there, some other content. So we've had some banners, but they're very basic. Right? It was, hey, it's your first login, show these two banners, and then you could X out of them. They really wouldn't show up again. As with the automated DMs, the automated notification engines that we built, we've realized that there's a lot of things that we would like to trigger as a call to action for users that are in-app. Push notifications are great. It gets you into the app, but sometimes in the app, we want to steer you to specific things based on actions you've taken, initiatives we're driving, things to help support backers supporting proteges and proteges sharing their success. So like we did with the notifications, worked with the product and the community team to come up with a large rule set of, if this thing happens, show this kind of a banner. If it's been this long, show this other banner. And we broke it down again into some time-sensitive things, some action-based things, some reaction-based things, and came up with, again, a whole rule set and a bunch of different banners that would steer people to different places within the app that we are now challenged with. How do we build that in our platform?
Oh, yes. Yeah, that's a, yeah, absolutely. Now I'm recalling exactly what the problem was with implementing such a system. When you load the feed or load the homepage, now that's not the right time to compute whether or not you need 25 banners, or which of the 30 conditions you apply to. And so we need to design a new type of system where we would essentially compute which banners you're available to see, as a result of the events happening through the system. I think that's sort of like that's the current thought. And if that sounds familiar, Dustin, maybe you can tell us a little bit about the proposed architecture. Now, this is like live. It's still being evaluated by Andrew. So
Yeah, no,
pick it apart right now.
it's super familiar because we're still in the middle. Well, yeah, we're in the middle of designing it. At least the detail parts of it. I think we have the high level architecture of it done, and it fits really nicely into the things that we've kind of already built.
I do want to say that one of the reasons we're going down this path for a new architecture on this system is when it was 1 or 2 banners, computing when a screen loaded wasn't a big deal.
Right.
Doing this for 25 or 30 use cases every time for every user is so prohibitively expensive that it was just a non-starter. So we've got to rethink this. We have to come up with a more elegant and efficient way to sort this out that's much more proactive than reactive, where the app loads and it goes, hey, do I need to see anything? Run all these computations. We don't want to do that every time.
I've got a diagram. So what we have is this is the kind of the high level blueprint for how we're going to manage something like this. So over here, we kind of have our events, right? Either client side events or user driven events. That's the first class of things that are going to happen. User does something, or something happens to the user on the back end that triggers an event, right? And so that event bus we talked about earlier, that pipe, right, that we can put events into, rather than having a job schedule in that, we are going to put them in as they happen, right? So an event, a user makes a post or comments on a post, engages with their protege in any number of ways. We're going to stick that in the event with whatever relevant context, who the user is, who the protege is, what they did, put that into the event bus. That event can be listened to a number of different handlers, one of which will be this event, kind of the banners event manager. This basically holds all the rules, what's supposed to happen when this event occurs. This is where some of the complexity obviously starts to get in, but essentially it's going to say, I need to display a banner at this particular time, or I need to schedule banners A, B, and C to fire in some way. So the plan is any immediate job we're going to throw into another SQS queue, and that SQS queue will be observed by an execution manager. And this handler's job is to actually, let's say, update the user's banner state. Say, hey, you're supposed to be seeing these 3 banners. I'm going to send it to your phone next time you log in or do a certain page. For things like, there's certain rules about, after 2 weeks, you've been on a protege's team for 2 weeks now, we're going to hide one banner and we're going to give you the next banner in this series. Those events we're going to pre-schedule, and we're going to just sit those into a table and have, like, we call them watch objects. They're really jobs. And we're going to let those sit. And then we will, going back up here to the event bus, using that job schedule that we talked about that drives our automated direct messages, we will have this scheduler put an event in, say, hey, evaluate my jobs table, my watch objects table, and anything that's supposed to happen today, throw it onto the queue and execute it. And there's implementation details about how you clean up these jobs that are supposed to happen that now shouldn't happen, how that interacts with the user banners. But the main thing that we're adding now is this event-driven architecture to where we actually are dynamically putting events in live to the system and responding to those events in asynchronous manner.
Wow, Dustin, thank you for that. That's a very clean explanation of the system that we're proposing, and it does build on all the Lego blocks that have been hardened from the previous other two use cases. So I feel like it feels good in my head, Andrew. I think if we want to do this, it's modular too, right? You can see. So yeah,
it's a great going down this journey of fixing notifications, building the ADM bus like that, and then into this. These are all just stacked on top of each other, right? The lessons we learned step of the way help identify an elegant way to solve this problem. I also want to give you another shout out. I know you've been mentoring one of our devs on helping to create that design.
Yes,
that you've been pairing with them, and for as an engineering leader on our dev team, seeing they started as junior devs and they're being mentored by both you and Aron has been great. And so it's cool to see that document and seeing how both of you have built that up. And so it's just great to see that coming together as a team.
Yeah, it's fun. I've got a totally different design, and his input completely changed it. And there's a lot more squiggly lines on the new one than there was on the old one. So
Brandon, if you ever watch this, thank you.
Yeah.
Yeah, that was really fun to see. Like we came up with like, okay, here's a design. Then gave it to Brandon, and Brandon like analyzed it and said, what about these use cases? We're like, oh yeah, okay. Then we iterated, and then now we had this thing, and he fire tested that one. It truly was a fun, kind of collaborative experience. And it is a kind of a backing too, isn't it? Right? Kind of like just mentoring, which is really a nice experience to be able to help out with the team. And in all these months we've been working with them, it's been a really rewarding experience to work together to help mentor and bring up the team.
It's been great. It's part of our mission at Backrs to do that. We're provided to others, but we do it internally too. So yeah, it's cool to go through a design and like, yeah. And I remember where Brandon had started his journey and seeing that, and then going through it together with us is really cool.
And I can kind of now that we talked through it all, it's kind of a great arc. It's like sort of like starting and refining these things, right? With just what's needed at the time, but building it in such a way that it can be used as stable, tested Lego blocks for the next thing, right? So, and learning at each step and building it up incrementally. So that's it's been nice to like see the whole journey, and that's why I like talking with our group here right now, just talking through it. It's like a story arc. It's nice.
And to the next chapter and Aron and Dustin, we've talked about this already. This feature we're building right now for banners, we're going to leverage it for the next integration we're building. We're already looking ahead, going, we know we'll need to support this other thing later, and that's a time for another discussion, but it's the same thing. We're building one thing, looking ahead at the next. I want to build it once and support multiple features. It's really good to see that in practice.
Each piece unlocks.
Exactly.
I know that in future we could talk about how Olio apps and Backrs like collaborates using artificial intelligence. And actually that's an entirely different topic, and one that has got energy in Backrs and in Olio apps as well. So perhaps we can talk about that some other time. Yeah, we'll have to have a part 2.
I'm ready for it.
Well, thank you guys. I really appreciate everything. All
Absolutely.
right, thanks.
Thanks for having me.
Thank you.
Yep.
Take care.